Hi everyone, Professor Bob Young back at you here. In this instructional video, we're going to look at variation problems that not only will you use in math class, but also business classes, science classes, and many other applications in the real world. So looking at the supplemental handout here that you can find in your course, number one, there's three types of variation. The first is called direct variation. And you'll be able to tell in the word problems and how the problems are worded. For example, this one starts out y varies directly as x, or y is directly proportional to x. And you want to set this model up as y equals k times x. Now, a real life example in that you may be aware of is water, H2O. I mean, the water molecule has 2 atoms of hydrogen per every 1 atom of oxygen, so that is a directly related compound there. So without that, where would we be? And you say we never use this stuff in real life. The second type of variation is called inverse variation. Y varies inversely as x, or y is inversely proportional to x, and that is y equals k divided by x here. So notice on direct variation, we're talking about multiplication of items. Inverse variation, we're talking about division. And notice the wording is important as well. The third type of variation is called joint variation. Now that could be a combination of the above two. So for example, C varies directly as A and inversely as B. Well, notice I've got the model here to give you some different looks here, because getting that model is going to be huge. All right, so it says C equals K times A divided by B. So again, direct, notice, means multiply, and inverse, divide. All right, and the last example here of a joint variation problem, it says D varies directly as A, B, and C. So again, sometimes they don't even use the word directly in there. They'll put the word jointly in here. D varies jointly as A, B, and C. But if you don't see that word inverse in there, then go with multiplication here. Now, I noticed some of you said, Young, no matter what letters you've been talking about, there's always this K in here on this. Now, K is the thing that ties everything together, the most important part of it. It's called the constant of proportionality. All right, so as we continue here, it says to solve any variation problems, there's 4 steps. And the first one is huge, like I said before, establish a mathematical model using the given information. Okay, get K with that information provided. So they're going to give you enough information to tie the variables together. Plug K back in to get a new model on how they're all related from that point, and solve. All right, so let's go ahead and look at some examples here. Example 1 says if A varies directly as B, stop there. So when you see this, you want to go ahead and set it up. So we're going to say, since it's direct variation, A equals K times B. Now, if this word here was inversely, it would be K divided by B. So again, getting this model is 90% of the battle. Next, step 2, use the given information to get K. So it goes on to say when A equals 9, when B equals 30. Okay, so we're going to plug in those numbers. So to solve for K here, the constant of proportionality, we're going to divide both sides of the equation by 30. And K is going to equal 9 over 30. Now make sure you reduce all fractions to lowest terms, would be 3/10. All right, so now we know how A and B are directly related. So we're going to plug this constant back into the model here to get the new model. A equals 3/10 times B, and then just solve. So notice it goes on to say find A when B equals 40. So we're going to say that is 3/10 times 40 will equal 10 cross cancels here. Oops, hang on a second. I kind of drugged that a little bit. All right, so 10 is going to cross cancel with 40 here. giving us 4 times 3. So the final answer for this first example will be 12. All right, continuing, example 2. Let's get some under our belts. The area of a rectangle varies directly as its length. All right, now notice in some of the word problems here that they are not giving you like nice things like up top here. So we're going to go ahead and set this one up very similarly, tying these two together. All right, so we're going to say area A, we'll go ahead and make up some creative variables here, varies directly as its length, so we're going to put K times L. So this is kind of like the way it'll look in word problems, but again, very similar to the first example. Now, use the given information to find K. It says if the area is 50 square meters, when the length is 15 meters, okay, so we'll go ahead and plug that in. So they will give you that information to solve and tie those variables together and get that constant of proportionality. All right, so again, you've got this fraction 50 over 15, so make sure all fractions are reduced. So 5 goes into 50, or let's put, 5 goes into 50, 10, 5 goes into 15, 3. So there is your constant that relates the area to the length. So rewriting that model here, we're going to have the area then is related to the length by a factor of 10 over 3. So we're going to say A equals K times L, 10/3 L, and now we can solve. It goes on to say find the area when the length is 25 meters. So we'll just go ahead and plug 25 in there. So that'll come out to equal what, about 250 over 3, and then sometimes they'll just say leave that answer in fractional form. Other times they'll say go ahead and write it as a decimal. So if wanted, or we could go ahead and write it like this: 3 goes into 25, what, 8 times? 8 times 3 is 24 with 1 left over. So we would come back and say that would be 83 1/3, or you could say 83.3 if you just were rounding, or 83.33. So that would be the correct response for number 2. All right, for example, the next example here, I'm just going to jump into the homework as you guys will see it here. And let me see if I can blow that up a little bit. In section 3.6, notice it says here if Z varies inversely as W, and we'll go on and stop right there. All right, so when I see that word inversely, I'm going to say Z equals K over W, or division there. So this is the first example where this wasn't a direct relationship in terms of multiply but divide. But once you start getting the hang of it, I think once you set that model up, you'll be in great shape. Now, once you get it, find K. It says in Z equals 4 when W equals 6. All right. So to solve for K here, we're going to multiply both sides by 6, or the LCD here. So the constant of proportionality K in this problem is 24. And then we will take that 24 and plug it back in to establish the relationship between Z and W here, the inverse relationship. So Z now will be 24 divided by W, and then solve. So it says then with this relationship, for all the other things that happen with this now, find Z when W equals 8. So if you know what you're doing, this is really just 24 divided by 8 for the final answer of 3. And yes, we will check it because I know everyone likes to in here. All right, so I'm going to plug the 3 in there, and nice work. All right. All right, let's go for an example for you business majors out there. Now notice in example 3 here, it says in a certain manufacturing process, the cost of producing a single item varies inversely as the square of the number of items produced. All right, so this one's got a lot more involved here. So again, you're going to have to pick some variables in here. And I think I'm going to call a creative variable for cost C equals, and it says varies inversely as the square of number of items produced. So I'm going to put K over I squared there. See, so you have to be careful on some of the key words in here when you're setting up these models as well. And if you did it right, when you go to get the constant, everything will fall in place for you. So let's see if it does for us. So it says if 100 items are produced, each costs $2. So then again, you have to be careful where to plug things. So 2 is C. The items produced, it says, is 100 items there. So we're going to take that number and square it. So to get the constant here, we're going to have to multiply both sides by 100 squared. So the constant of proportionality here, 100 squared would be, that'd be a 1 with 4 zeros, 10,000 times 2, so we would get a constant of proportionality of 20,000, and we will plug this back in. So I told y'all, if you're business major, science, there's a lot of different things here that you'll use these applications for. These variation problems, very important. All right, so we're going to rewrite that model, and then we can go ahead and relate that cost to items and so forth now. So it says find the cost per item if 400 items are produced. So we're going to now go ahead and plug that in for I. Okay, so if you use your calculator, if you figure this out by hand here, I believe you're going to come up with 20,000 divided by 400 square. Comes out a fraction 1/8. All right, now if you're talking money here, you don't want to be talking about 1/8. You want dollars and cents here. So I'm just popping this in my calculator here real quick. And I'm not plugging it in here. My calculator is just being fickle with me here. And I've got about, the cost is 0.125. Now again, you can, if you're a banker, what's 0.125? Well, it would be 12.5, 12 and a half cents really, if you want to go ahead and change that into dollars and cents. So make sure your answers make sense as well. Get it? Never mind. Stop it, Young. Sense. All right. But anyway, let's do a few more examples and we'll wrap up this section. We'll try to make these a little more challenging here, the last two here. So example 4 says, and this would kind of fool students sometimes, so be careful. The area of a triangle varies jointly as the lengths of the base and the height. Now, if you want to pause the video for a second, see if you can set up the model, because that's really the important part. Once you get that model, and you can even do it for number 5, if you want to go ahead and read through this, see if you can set those two models up, and we'll come back. You can come back, but I'm just going to keep on going. So if you haven't paused by now, I'm going to keep going. All right, so area, I'm going to call A, varies jointly as the lengths of the base and the height. So I'm going to call that K times B times H. All right. Now, wait a minute, Young. Where's the division here? It says varies jointly. Now, do y'all see any words in here that say inversely? No. Now, that's what I was trying to tell you again. They don't always use the words direct and inverse on every single one, and especially application problems. So jointly, directly. All right, if you don't see inversely, go multiplication on it. All right, so continuing, it says now you can get K and do the same thing. All right, if you want to pause here and finish it from there, get K, plug it back in, solve, do so. All right, but if not, we'll keep going. A triangle with a base of 10 feet, all right, and a height of 4 feet has an area of 20 square feet. So once again, they'll give you this information to get K. So we'll get 40K equals 20. Divide both sides by 40. Show your steps in here, because a lot of students don't show their steps and they get in trouble. So we're going to get K as 1/2, which we are going to take and rewrite that new model, and we will have all of these variables now related based on that first set of data. All right, find the area of the triangle now with a base 3 feet and height 8 feet. So it's 1/2 times 3 times 8. So that is going to be 24 times 1/2, or half of 24. The area would be 12 square feet. And make sure you put your units on here. Boy, when you guys get to the science classes, if you don't put your units, the science instructors, they will not be happy. All right, let's talk about the last example, and then I will turn y'all loose to go on your homework and stuff. It says the number of variations per second, the pitch of a steel guitar string varies directly as the square root of the tension and inversely as the length of the string. So you guitarists out there, don't get me started. Yes, there's mathematics in music. So I'm going to call the number of vibrations setting up this last model V equals, it says the steel guitar string varies directly as the square root of the tension. So I'm going to put K times the square root of T. Now again, be careful because we saw one that had a square involved. This has a square root. So reading the problem, important, and inversely as the length of the string. So I'll call that L. So if you can get to here, you can pause, get K, find the answer. I think you're going to be in great shape. All right, so let's continue here. So it says if the number of vibrations is per second is 50, okay, when the tension is 225 kilograms, I'll put 225 in for T here. Now, believe it or not, that is a nice square root number there, all right? And the length is 0.6. So they are just throwing all kinds of things at you. Square roots, decimals, don't let that bother you. It's just, you can get all this very easily here. So I'm going to go ahead in the next step and just say the square root of 225 is 15. Okay, and I'm going to leave the 0.6. Now again, to get rid of that fraction, multiply both sides by 0.6 here. Okay, so we'll end up with 15K equals is 30, and dividing both sides by 15, we get a nice K value of 2, which we are going to take and plug back in up top here and rewrite this model and then solve. All right, so, just be careful with how they word these now. So it says find the number of vibrations per second when the tension is 196 and the length is 0.65. So again, you may have to use your calculators a little bit on this, work on it, but that's okay. Let me go ahead and figure this out. All right, I got the answer of about 43.0769, and since they are after the number of vibrations, I guess we would have to put seconds in here. Now you have to be a little bit careful in the homework. Sometimes they'll say round this 2 places, 3 places, nearest tenth, whatever. So you're going to have to be careful on your rounding skills. But other than that, I am going to say this concludes the lesson on variation. Bob Young signing off. Bye.